All right, let's talk a little bit about the networks. GM and Chrysler both have controller area networks, as you know. In 2004-ish, the federal government came in and said, we want to start standardizing the network, just like we did engine performance with OBD2. And they came out with CAN, the CAN network, controller area network. So in the Chryslers, they're very dependent on the gateway module, or as we all know it, the TIPM, totally integrated power module. It's a good thing and it's a bad thing. This module has a lot of functions and a lot of computing power. To have it in the engine compartment, especially exposed to heat, and you put a Hemi in your Jeep or a supercharger next to that TIPM and you're asking for trouble. This gateway module is basically where most of the other modules on the network talk through. So, see if I can get a happy medium here on these wipers. And you can see I'm in tap shift mode here, locked in second gear, which seems to be about right for going down this hill. So the TIPM controls a lot of functions in your JK, not just power door locks, power windows, but it controls the fuel pump, it controls the charging system, it controls the cooling fans. So it's very integrated into engine performance. Now GM has what they call a body control module, and it controls most of the body functions like lights and things, but it also controls things like interior switches, like your cruise control switch and tap shift switch. It monitors system voltage and makes changes based on that. The BCM actually has a lot of input into engine performance, but it's not directly related to engine performance. Meaning a TIPM can shut you down, and they do. You have a fuel pump problem or a charging system problem. The BCM will not do that in general. So the approach is a little bit different between GM and Chrysler. Now, we can use this to our advantage by tapping into the TIPM and using the BCM. We can gain functionality in our swaps. For example, we mentioned the cruise control being run through the BCM. With our MoTech module, we can pretty much support most of the GM BCMs. So that would be the CTSV, the LS3, passenger car BCM, the truck BCMs, etc. And once we get the proper signal into the BCM, it does the rest. So if you were to enter the tap shift mode or the manual mode like I'm in right now, and you set cruise control, the BCM would interface those signals, and then the ECM and the TCM would take the appropriate actions to RPM match shift and keep you in the right gear and all that. So I'm going to turn on this air compressor and get rid of this humidity. Now, GM uses the BCM to monitor critical functions. For example, brake switch inputs. Brake switch inputs need to be redundant and separated for safety. So the BCM gets one signal and the ECM gets another, and they're opposite signals, just like the TIPM. Just like the TPS. So they're synchronized, meaning the BCM looks at one signal, the ECM looks at another signal, and they have to be synchronized and matched before certain functionalities will take place. Now in the Gen 5s, and some of the late Gen 4s, they run a brake pedal position sensor. The early Gen 4s, or later Gen 4s, ran a discrete and analog signal. So it had an on-off and a 0 to 5 volt signal. Almost all the new ones in the Gen 5s now run dual brake pedal position sensors, and they're opposite, just like the TPS, so that if there is a failure, they'll separate, and they will put you into a reduced power mode. So yes, your brake pedal switch can put you into a reduced power mode in a Gen 5 engine. And this is why it's critical that we work within the factory calibration and hardware. Now, can you throw in a GM performance tune? Can you bypass and turn these things off? Yeah, of course you can. But now you're losing that functionality, and you're probably losing things that you don't know. Everything in these CAN networks is integrated to work with each other. So when your transmission makes a shift and you're in cruise control while in the manual mode, there's all sorts of things going on. RPM match shifting, the engine's changing its torque for anti-clunk protection, and all these things are working together to make the shift as seamless as possible and still hold the speed that you want. Without integrating those modules, you can't do that. So yes, there are hacks, there are bypasses, but we choose to not do that if possible. GM uses these separate brake switch inputs, where Chrysler does use separate brake switch inputs, but they both go into the PCM. The earlier JKs had what's called a powertrain control module. Powertrain control modules, like the NGC4, use two separate brake switch inputs, a high and a low, and two separate cruise control switch inputs. And then those are rationality checked by the PCM for failures and codes and such. Now, that's not quite as sophisticated monitoring as GM uses by separating modules, but it's there and it works. So we may be able to tap into that to gain some efficiencies. Personally, I think the separated redundant sensors is the better deal, and believe it or not, we've had a lot of brake switch failures in these JKs. So it works. The monitoring on those systems do work. GM tends to keep their engine performance isolated from the remainder of the network. And what I mean by that is, if you look at the GM ECM, it senses air conditioning pressure and brake switch inputs and pretty much everything that's required to run the engine. They don't spread things around like Chrysler does. Chrysler's very dependent on the CAN network. You have a module on your dash. It is your instrument cluster. It's called the cab module. That has a lot of functions that GM would have inside of their ECM. So I like the fact that GM integrates most of their engine performance parameters in engine performance modules and doesn't spread them out. It makes it easier for us to integrate engine performance with limp modes and reduced power modes more efficiently and more safely. So these are all the things that are going through our R&D when we develop these systems. Can you make a JK run and appear functional without a lot of effort? Yeah, there's guys. We helped a guy with a Duramax recently, full-size Duramax. We helped a guy with a big block Chevy. We've helped a couple of buggy builds, even with some of the big guys like Jen Wright. But to actually get that OEM level of performance and not GM performance, or not an OEM operating system that's been hacked, and a lot of the Hemis are hacked, where they import and patch engine performance parameters into a V6 PCM, ECM. We're talking calibrations that are the way they were submitted to the US EPA, run the same way they were submitted to the US EPA. And I gotta say, we've got a couple of hundred of these JKs out there, and this one, for example, this thing has been on the road for many, many, many thousands of miles, and a lot of it off-road. And one of the things that keeps them on the road is this factory level of monitoring and safety. There are, like we discussed, all sorts of safety modes where the computer will pull spark back. If you have a cylinder misfire, it'll deactivate that cylinder. Hot engine protection, oil aeration, low oil. So by implementing all those and keeping them in the circuit, these vehicles can run as the manufacturer intended. Because remember, GM could get more performance out of these engines if they wanted to, but they have to make these engines survive for hundreds of thousands of miles, at least past the warranty period, and they have to survive in different environments. I'm in the desert right now, and it was over 100 degrees here just a few months ago, and now it's 50 degrees. So GM has to make sure that these things survive in all these different environments, and that's why they incorporate all this software and monitoring. And if you go with a GM performance product or a factory network that has these functions bypassed and not functional, then yes, it'll run, it'll appear fine, but it's not an OE level conversion that integrates the safety and reliability and functionality of the original vehicle. For instance, you can put a aftermarket cruise control in a Gen 4, pretty much plug and play, and they work great. We've done Rostra plug and play pedal modifiers, and they work awesome. So you compare that to a factory cruise control unit, and they're not the same. If you look at the level of monitoring, and when you are going up a steep mountain pass or going down a steep mountain pass, like in the Gen 5s now with brake pedal position sensors, it can actually pick up that you're riding your brakes while you're in the cruise mode, and then downshift and react to that brake input. So there's all sorts of things that you're not seeing by doing a patched or a hacked conversion. And while you guys don't see everything that goes on in the background on our side and all the diligence and R&D to make these swaps functional and reliable, it's there. And I think that we're going to start showing you more of it, because it really is fascinating. And yeah, I've been doing engine conversions for over 30 years, going on 35 years, and every year things get more complex. And year after year, as the technology develops, it's not that much of a shock to see what happened from last year to this year. But when I look at what has happened over the lifespan of my own engine conversion experience, which is about 35 years, it's unbelievable. When I started doing engine swaps in the late 1970s, early 1980s, we were using small block Chevys. There was really nothing else to use. We did some small block Ford swaps, of course. We even did a Hemi swap, an early Hemi swap. But if you look at that small block Chevy compared to a Gen 5 LS with direct injection, I mean, not even the Europeans had that technology back then. I mean, the technology existed, but it wasn't implemented. So we've come leaps and bounds. And if you look at a Gen 3, not a Gen 3, if you look at a small block from the 90s, let's say a 5.7 liter K motor, they're rated 180 horsepower, 190 horsepower. Just a lowly 5.3 today is rated at over 300 horsepower. It's amazing. And these new Gen 4s and Gen 5s pushing 400 horsepower and still getting good economy, it really is amazing. So I think that's enough rambling for right now. I'll come back and we'll discuss shifting patterns and different reduced power modes, and maybe some more functionalities of processing and integrating and bridging the signals between vehicles. And I'm not just specifically talking about JKs, and there's a big difference between JKs when you compare to 3.8 and to 3.6, but we're talking about TJs, LJs, XJs, SJs. We've done SJs, Toyotas, Broncos, you name it, and they're all the same. They're all just signals in and out and how you process them. So I'll try to put a little bit more of that stuff up if you guys find it interesting. Really, I thought that this was boring for most of you guys, but I get more reaction on these talks than I do on showing a burnout. So I think we'll do some more of this talking. Now you'll notice that on this, that the tire light and the security lights flashing. This is an anomaly of the early TIPM. I think this is an 8 or a 9 vehicle, and they will do this when the tire pressure is low or high. The tire pressure is low in this one right now, but they'll even do it when the tire pressure is right, and the dealer and Chrysler really has no fix for it. It's a bug in the CAN network, so you just got to live with it. But legitimately, this one does have low tire pressure, so you know, we'll deal with that. And yeah, I really don't want to wash this guy's Jeep, so let's go around this mud hole. Wow, the weather's getting pretty crappy out there. Well, he's going to be happy to know that he didn't have an oil leak, that it was just 5 quarts over full. Unfortunately, it does not seem like the engine was damaged. I really recommend you check your transmission and engine levels carefully, because these LSs are not as tolerant as the earlier vehicles with oil grade. You want to run that Dexos in the LS3s. I just had a customer who ran 530 conventional, and it ran fine in his 6.2. It ran fine for about 2 years, and then he started blowing smoke. And what happened was there's really tiny, small little passages in the driver's side valve cover for the PCV breather. The PCV is built into the driver's side valve cover, and in 910, these passages are really small, so they would plug up, and when they plugged up, the PCV no longer could breathe efficiently, and you would start pulling oil into the intake. And once you did that, on fire up, you get a plume of smoke. So that's what happened. We ended up replacing the valve cover, changing the oil out to synthetic, and he hasn't had a problem since. So follow the recommended oil level and grade. Use Dextron 6 in your transmission. Use Dexos in the 6.2s, and you can use conventional in the 6.0s and the 5.3s. All right, that's enough.